examples, and I'm going to go ahead and leave them in here. These are a little more complicated. Actually, you have a homework that's kind of like this. Your test questions will be less like this and more like the previous example, but I want to take it up a notch and kind of work with larger distances and larger times. So this is the question. It's very similar to what we looked at before. Basically, yeah, so we're supposed to come up with what is the speed, the average speed of light as it travels from the Earth to the Sun. And notice that for speed, we said, average speed, I'll just go ahead and say speed, we said that you take distance divided by time. And let's look over in the diagram to see if we can come up with a distance. I can have a distance of 1.50 times 10 to the 8th kilometers. Now this is where we talked about, this is a number packed up in scientific notation. Distance divided by time. Time we have is 500 seconds. Great. Okay, we can do that because we're supposed to come up with the speed in kilometers per second. So actually, I didn't do this ahead of time, so I'm going to take a minute and do it on my calculator. Feel free to do it on your calculator. I am putting in 1.5. In my calculator, I've got an EE key. Yours might be different. Hitting EE, hitting the 8, and then I simply hit the divide by key, 500. Okay, my calculators just display 300,000 equals 300,000. Don't forget our units. Units would be kilometers per or slash second. km/s. Right? One more thing before we leave this, and that's actually the right answer. Before we leave this, I'm going to go ahead and pack this up in scientific notation. We kind of have a decimal hiding over here. And so I'm going to move it 1, 2, 3, 4, 5 places. So I get 3 times 10 to the 5th kilometers per second. And that is the speed of light. Okay, notice one of the cool things is, well, that's okay. We'll talk more about that later. Okay. So, let's go ahead and I'm not going to make this into a video question. We're going to go ahead and do this together. So let's use...
I didn't understand the question I heard.
Let's go ahead and use that. Thanks you, Alexa. So let's go ahead and use this as use that 3 times 10 to the 5th kilometers per second in a problem. So the distance from here to Mars, a very busy place right now. From here to Mars, we've got all sorts of human satellites looking at Mars. Is this number? Looks like 225,300,000 kilometers from Earth. And the question is, how long does it take in seconds and then in minutes, oh my goodness, for light to travel from Mars to the Earth? So I'm going to go ahead and I'm going to write it up. Well, let's see, where should I write it? I'll write it down here. We came up with the speed of light as, I'll write it up here. We came up with the speed of light as 3 times 10 to the 5th kilometers per second, right? Now, when I go to work this problem, I'm going to want to unpack these. That km/s doesn't work very well when I want to have things cancel. So I'm going to rewrite that as 3 times 10 to the 5th km in the top, in the numerator, per 1 second. It's the same deal. So now I'm going to use that to my advantage down here. And I recognize that I'm going to go ahead and as my second term, I'm going to have the distance between the Earth and Mars, 225, 300, 000 km. Okay. And I'm trying to get to seconds. So does this make sense that if I want my kilometers to cancel, I'm actually going to have what? Kilometers down here in the bottom of the first term. So this is a case where my kilometers needs to be in the bottom. So I could take this and I actually could restate that as in 1 second, light will travel 3 times 10 to the 5th kilometers. That's the same thing as the speed of light, except what we call the inverse or the flipped version. So actually that is what I'm going to put down here. I'm going to put 1 second over 3 times 10 to the 5th kilometers. Cool. So wow, and I always focus on my units first, how I have my units set up. So if I do that, kilometers will cancel and I'll be left with units of seconds, which is exactly what I want. So I'm going to take a minute and go ahead and put that in my calculator. I put 225,300,000 divided by 3 times 10 to the 5th, so 3, and then I find my EE key. In my case, might be different for you, might be EXP or SCI, or times 10 to the X. And I'm going to hit the letter 5 for the power of 10, and I'm going to go ahead and put enter. And I got 751. 751 seconds. And you could go ahead and leave that and you get the right answer. I hesitate to emphasize this too much, but honestly, when I go to round this number, I have to see what digits I had in what I divided. And I know it doesn't quite seem right, but actually I only had 1 digit here. So I would really only be allowed, what we say, around it to 1 digit here. I know that sounds weird, okay? So probably even a better answer than that would be this one, where we go with, if I'm going to go with 1 digit, it's going to be the digit in the hundreds place. And since this is a 5, I'm going to round that 7 up to an 8. So honestly, it would be 800 seconds would be a better answer. So the last question is, what is the time? So that's in seconds, and the question is, what is the time in minutes? So I'm going to kind of show you a trick to do this, and let's see if I have room up here to do this. Here, I'm going to do this in the upper right hand corner up here. So basically what I want to do is go from 800 seconds, I want to know how many minutes that is. Units of minutes. And if I were to ask you how many seconds in a minute, you probably would say 60. So 60 seconds equals 1 minute. So in other words, there is 1 minute per 60 seconds. And I did that on purpose up here because now if I go ahead and plug that, what we call ratio right there, now my seconds will cancel, so I'm going to put 1 minute over 60 seconds. That's always, it doesn't have to do with this problem, that just always is the deal. So my seconds will cancel, and I'm left with the units of minutes, which is what I want to be left with. So now if I divide 800 divided by 60, I get 13.3 repeating. So I'll just go ahead and put 13 minutes here. Okay. One last thing then, if you're going to round this, all right, I know it feels weird, but again, if we're going to round it, we only have one significant figure here, and actually there's no uncertainty brought here, but I'll go ahead and put 1. So the point is that we're only allowed 1 digit here. If you put 13, you get the right answer. But actually, what it really probably should be, according to rules of rounding, is 10 minutes. Because that 3 is less than 5, and we just leave that 1 the way it is. Whew, all right then. So now you have an assignment to do to work out and probably bring with you Thursday night, or scan and put in the Dropbox. But this actually, the first question up here, you have the answer to, which seems kind of weird. You're like, Mrs. Snipes, are you sure? There's the right answer right there. Well, I want you to go ahead and set it up and work it. So remember that what I said is anytime you see like this meters per second here, M/S, I would unpack that to what does that really mean? Well, it really means that there are 3.00 times 10 to the 8th meters in one, or per 1 second. That's how far it will go in 1 second. I guess I wished, now I see in retrospect, I'm not going to emphasize converting within the metric system too much. So if you want to, this right up here, and some of you could already do this, I'm sure, that value actually in meters would be 7.86 times 10 to the, times 10 to the 9th meters, if you want to go ahead and use that. Now, as I've shown it, it's not ready to multiply, is it? We're not ready to multiply. Why? Because our meters won't cancel. To get the meters to cancel and to be left with seconds, here's my hint. You're going to have to, this is my swing it around, you're going to have to basically flip that thing over. And then meters will cancel and you'll be left with units of seconds. So that's my hint for that one. The hint down here,